Uh, Dear learners, welcome to the sixth experiment of Linear Algebra Laboratory, where we are going to see the solution of a matrix using Gaussian elimination without partial pivoting. So I just want you to recollect the theory topic, that is Gaussian elimination with partial pivoting, where you should identify the difference that the theory portion dealt with partial pivoting, whereas for the practical session you are dealing with without partial pivoting. So the difference is that you need not identify the pivot like this. There was a pivot you have to identify in the theory portion, but you need not identify a pivot here. Rather, you simply have to solve the matrix straight away, where you are going to divide it with the first element, and you are going to make the remaining elements 0 in the column. All these kind of things are required, but you need not identify the pivot element. So let's see how it is being done. Okay, now here is a program. So in this program, what you do is you will be first of all doing the import of the OS and as well as the environmental variables. Thereafter, definitely, since it is a matrix problem, you have to include the numpy, and also there is one more library that you have to include, which is nothing but the sys, which is a library that is being used to interact with the operating system. So why it is being used, I'll let you know. And first thing that you have to do is you have to enter the number of rows, how many rows are required and how many columns are required. That is what you have to enter here. That is what is being given as n is equal to int input. So whatever value that is being given, that will be converted into integer. So here we are dealing with a 3 by 3 matrix. Okay, so that is being given as this 3. This input being given as 3. So you need not enter anything. It will be given in the backend, right? And thereafter, we have to enter the matrix like this. That is, you have to enter a 0 matrix n comma n plus 1, and this is used to accommodate the constant part as well. So this is being given as an augmented matrix. This is an augmented matrix. And finally, there is something known as the x, which is being used to get the solution. Okay, and afterwards what you do is you will be entering the values for the matrix like this. That is, first the first row will be filled, and the first row will be filled and the corresponding columns of the first row will be filled. Then the next row and the corresponding columns, the next row and the corresponding columns will be filled like this. And thereafter, you are going to check whether the diagonal elements are going to be 0. Why? Because you always divide the elements, the whole row with the diagonal elements, isn't it? That is mostly the leading one part that will be divided by the diagonal elements. So hence it should not be equal to 0. So that is what is being checked here. That is aii is equal to 0. So if it is if any of the diagonal elements are equal to 0, means suddenly the system will exit and it will show like this. This is where you are making use of this particular library, the sys. The program will exit gracefully without causing any problem like an error. Okay, so straight away it will write and divide by 0 detected, and it will exit the program. And thereafter what happens is that it is trying to create a value known as the ratio, where you are going to divide the remaining row elements by the corresponding leading element. Okay, so this is the leading element. As you can see, this is the same diagonal element being used. So every row is being divided by the corresponding leading element, and afterwards this is where you are going to subtract the leading element from the previous element. So this is what is being done here, and you will be able to get the reduced matrix in the upcoming iterations and calculations. So thereafter what you do is you are getting the solution of this equation using this formula: x of n minus 1 equals a of n minus 1 n by a of n minus 1 n minus 1. So you have to be pretty much clear about how we are doing with the Gaussian elimination with partial pivoting, this portion, where each element is being subtracted from the previous row. All these kind of things you have to be pretty much thorough, and afterwards you have to do this. Only difference is that you are not going to deal with any pivot element. Then afterwards you are going to substitute all these values onto the original matrix. That is what is being done here. Okay, and finally you're going to display it like this, and so you will be getting the solution like this. That is three solutions for a 3 by 3 matrix: x0, x1 and x2. Thank you.